Hello everyone, welcome to TIC. This is Kushal and today we will be taking the second problem from buy and sell stock series, best time to buy and sell stock 2. So let's see what the question has to say. So just like the previous question, we will be given an integer array of prices of stocks on different days. Now we need to design an algorithm to get the maximum profit out of it. Okay, in the previous question we were allowed to do only one transaction, right? Here it is said that you may complete as many transactions as you like. So we can do more than one transaction. Okay, so how does that going to affect the question? So if this was the question, 715364, I would buy the stock at 1, sell it at 5, one transaction, again buy it at 3 and sell it at 6. So the total profit will be 4 plus 3, 7. Another example, 1, 2, 3, 4, 5. So in this example, if I buy the stock at 1, I would sell it at 5. So the total profit will be 4. So what do you think would happen in this last example? 7, 6, 4, 3, 1. So if you look at the numbers carefully, you will notice that they are in decreasing order. So there is no meaning of buying and selling stock here. The maximum profit will be 0. So these are the transactions that we made. 1 to 5, 3 to 6 and 1, 2, 3, 4, 5. You notice something over here? So the transactions that we have made are always in increasing order. 1, 2, 3, 4, 5. 1, 5, 3, 6. So if we find all the increasing subsequences in our array, we can get the answer, right? So that should be your first intuition and that would work for sure. But there is an easier way to deal with things. Look at it carefully. So while you are traversing the array, if the number you are at is greater than its previous number, you would add its difference to the result. So 5 minus 1 to the result 4. Now we are at 3. 3 is lesser than 5, right? So it doesn't work. 6. 6 is greater than 3, right? So we would add its difference 3 to the result. So the total answer will be 4 plus 3, 7. Next example, as 1 has no previous, we'll be starting with 2. 2 is greater than 1, so we would add its difference 2 minus 1 to the result. Okay, 3. 3 is greater than 2. We would add 3 minus 2 to the result. 4 is greater than 3, so we would add its difference 4 minus 3 to the result. And just like that, 5 minus 4, 1 to the result. So the total answer will be 4. So what we did was same as finding all the increasing subsequences and getting the profit. Let's quickly code this approach. Okay, in the beginning we're gonna check for some edge cases. If price is equal to null or prices dot length equal to 0. If that's the case, we're just gonna return 0. Let's quickly initialize the variable called result in which we'll be storing all the profits. 0. And now we will be iterating through the array for integer I is equal to 1. We will be starting from the first index as the 0th index doesn't have any previous element. Okay, we will be iterating till the last element, I plus plus. If prices of I is greater than prices of I minus 1, the previous index will be adding the value to result, right? Prices of I minus prices of I minus 1. Okay, after the loop, we'll be directly returning the result array. Let's quickly run the code. Perfect. Let's submit it. Awesome. So our solution is faster than the 100% of the solutions. So what would be the time and space complexity here? As we're just iterating through the array, the time complexity will be of n, right? Space complexity, as we are not using any extra space, the space complexity will be of 1. So that concludes the video. Thank you everyone for watching. Please like, share and subscribe. And do not miss the next videos of this series. Thank you.